This video is on applications of the definite integral. So we're going to look at this word problem here. You might want to pause this just to write it down, but I'll read it out loud. So suppose y is profit per mile traveled. All right, so profit per mile traveled, and x is the number of miles traveled in thousands. That's important to know your units. It says find the area under the curve y equals 1 over x over the interval from 1 to 4 and interpret the significance of that area. So the first thing you might want to do is sketch it. You don't have to, but it'll help you kind of understand what you're looking at. So if I was looking at an x and y axis here, here's x, here's y, and I was going to draw the function in y equals 1 over x, you should know what that looks like. Kind of looks like this. You know, it comes downward. I'm doing a kind of zoomed in view. But the curve comes down towards the x-axis. It has an asymptote at y equals 0. It also has an asymptote at x equals 0. So, you know, it doesn't touch either axis, but it approaches them. What we're looking at, right, this is y equals 1 over x. And this is for positive values of x, right? I'm really not worried about what happens when x becomes negative because x is miles traveled. What I'm looking at is I want to find, you know, the area under the curve from 1 to 4. So if I said 1 was here, and 4 was here, you know, the area we're talking about is I'm trying to find this area here. Now, since our function is non-negative, right, it's all above the axis on the interval from 1 to 4, I don't have to worry about anything else when I'm finding the area except for taking the definite integral. If there was negative pieces to this function where it went below the axis, you would have to, you know, split up the domain and then work on it in 2 sections like we did in the last example, in the last video. So for my solution here, all right, the first thing I'm going to do is I'm going to say, okay, well, how do you get the area under the curve? Well, we're going to take the definite integral. And it's the integral over the interval from 1 to 4, right? That's our a to b. So it's going to be the integral from 1 to 4 of our function, which was 1 over x dx. And so you need to know the antiderivative of 1 over x. Now be careful here, this is our special case. Right? If I say 1 over x, right, don't rewrite this as x to the negative 1, because when you go to integrate then, you would have to add 1 to the exponent, which would make the exponent 0, but then you have to divide by that exponent, which would make it undefined. So 1 over x is our special case. What function, when I take the derivative, gives me 1 over x? In other words, what's the antiderivative of 1 over x? And that function was natural log, remember? That's the natural log absolute value of x. And we're evaluating this from 1 to 4, right? So the antiderivative of 1 over x is always natural log of x. Make sure you know that. And then evaluating this, you know, we're going to substitute in upper limit minus substituting in the lower limit. So we're going to take the natural log of 4. I'll put the absolute value bars there, but since 4 is positive, you don't really need to worry about it. Minus the natural log of the absolute value of 1. The natural log of 4, I'll just write it as natural log of 4. You don't need the absolute value, it's already positive. What's the natural log of 1 though? That's important. Remember what this means. It means e to what power gives me 1, because log is base e. Well, it's e to the 0 power. Log of 1 is always 0, no matter what the base. So we get ln of 4 minus 0, which equals ln of 4. And that's good. This was the exact value. So if I was saying what's the exact area is ln 4. But in this example, they want us to talk about, they said y is profit per mile, and x is the number of miles in thousands. So, you know, it's helpful to approximate this because we're trying to talk about, you know, what this really would mean in terms of profit. So if I was to approximate this, right, the approximation, you can use your calculator to approximate it. Natural log 4, and I get 1.38629. I'll just use approximately 1.386. Let's talk about units on this. Remember, this is an area, the area under the curve here. If you're not sure about the units of area here would be the units of the x-axis times the units of the y-axis, right? Just like when you're taking area using rectangles, right? It was this times this. So if it was length times width, you would be multiplying those together. So our units on this 1.386. Well, what are the units of the x-axis? Well, they told us x was in number of miles traveled in thousands. And what was the units of the y-axis? Well, y was the rate of change of profit, right? It was profit per mile. So it's really, this is profit per mile times the x-axis units, which was in thousands of miles. And if I'm using this 1.386, that's still my approximation, 1.386. And let's talk about what that means. So profit per mile times thousands of miles. Well, the miles will cancel with the miles, but you can't cancel the thousands, right? So this is the miles will cancel with the miles in the denominator, but this is profit, if you're thinking about it, times thousands. Well, what are those really measured in? Thousands of what? Well, profit is dollars and thousands. So it's thousands of dollars. So it's 1.386 thousands of dollars. And the way you can find that is you really can just take this and multiply your value times 1,000. So we get 1,386.29. So if you were approximating this, we have this times 1,000 would be 1,386, and then what is this? Well, this is dollars. This is an approximation. I'll leave off the change because I didn't have it here, but if you really wanted to be more accurate and use this number, you could say in 30 cents, depending on where they told you to round to. So $1,386. Now, what is this? So we found it. We said it's the profit in thousands, but where we are in the graph matters. So this was the profit in thousands over what interval? Well, when x is going from 1 to 4, it's between, x was number of miles traveled in thousands. So it's actually the profit earned between when you traveled 1,000 and 4,000 miles. So this says the profit earned is $1,386 when traveled between 1,000 and 4,000 miles. So when you travel between 1,000 and 4,000 miles, the profit you earned was $1,386. All right, so just using an application type example there. We'll do one more. It's going to be a little different, but same type of idea. So, and realize when they told us our function here, y is profit per mile traveled, that was the derivative of a profit function per mile. When you say that word per in there, it's the derivative. That's how we knew this was going to be profit here at the end. Let's take a look at one more. So if we said in this example, a candy store finds marginal revenue. When we say marginal revenue, remember that's the derivative of revenue. So finds marginal revenue in dollars from the sale of X pounds of candy. Is given by, and they give us a function r prime of x equals 6x to the negative 1/6 power, and they want us to find the revenue when 300 pounds of candy is sold. All right, so candy store finds marginal revenue in dollars, all right, from the sale of X pounds of candy, so X is in pounds of candy, is given by this function R prime of X equals 6 times X to the negative 1/6 power. They want us to find the revenue when 300 pounds of candy is sold. So first off, when they're asking you to find the revenue, you know that, marginal revenue was the derivative of revenue. So they're saying take the antiderivative of R prime, and that'll get you to revenue. So for our solution, we know we're taking the antiderivative of 6x to the negative 1/6 dx. Now, we have to come up with our limits of integration here if we're going to use a definite integral. Now, it says find the revenue when 300 pounds of candy is sold. Well, really what it's saying is, you started off by selling 0 pounds of candy. So your lower limit of integration is 0, and the upper limit is 300, right? So you're selling 0 pounds of candy up to 300 pounds of candy. The area under this curve will give us, the revenue once you evaluate this definite integral. It also gives you the net change in revenue if this curve ever went negative. In this case, it wouldn't, because when you have x to a power, those values will always be positive. So evaluating this, take the antiderivative first. 6 is a constant in front, stays in front. X to the negative 1/6, remember what you do, you add 1 to the exponent. So negative 1/6 plus 1 will give you 5/6. And then you want to divide by that same new power, so I'm going to divide by 5/6, making sure you can see that. And this is all evaluated from 0 to 300. And just to point something out here, when you're adding 1 to this exponent, if you really just add whatever the value of your denominator is to your numerator, that's how you can get it. It's the same as adding 1, because 1 is always going to be the same denominator over numerator. So it's a quick way to get there. Negative 1/6 plus 1 gives you 5/6. You're dividing by the same 5/6. The 6 in front just stayed. Let's simplify this. This gives me 6 times, when you divide by a fraction, you multiply by the reciprocal, so times 6/5 times x to the 5/6. And we're going to evaluate this from 0 to 300. This equals 6 times 6 would be 36/5 times x to the 5/6 from 0 to 300. And then make sure you remember how to evaluate here. You substitute in the upper limit first, so we have 36 over 5 times 300 to the 5/6 power, minus substituting in the lower limit, we'd have 36 over 5 times 0 to the 5/6 power. Well, 0 to the 5/6 is going to be 0. This whole last term will then become 0. So we really just got 36/5 times 300 to the 5/6. Now, this isn't going to come out nice, and that would be an exact answer, but because we're trying to find the revenue with 300 pounds of candy sold, we're talking about money here. Let's approximate that, and we'll use 2 decimal places. So I got 36 divided by 5 times, this will be 300 to the power of 5 divided by 6. Make sure that 5/6 is in parentheses. Otherwise, it might not work out appropriately. If your calculator does not display everything on the screen, take 300 to the 5/6 power first, then multiply by 36 and divide by 5. I end up with 834.34, or 834.834. So 834.83. So this equals 834.83. What are the units on it? Well, remember what we're finding. We're finding the revenue, so the units on this are dollars. And be specific. This is the revenue, right? This is the revenue when what? When 300 pounds of candy is sold. So because they didn't tell you the starting point, you're just saying, when I started it was at 0 pounds of candy, and then I sold up to 300. But they could ask you a question like, find the revenue earned between when 100 pounds and 300 pounds of candy is sold. If they asked you something like that, then you would change your lower limit from 100 to 300. It would change your answer. It would tell you how much of that revenue was earned between when you sold 100 and 300 pounds. Kind of similar to the last example where we were talking about the profit earned was between the 1,000 and the 4,000 miles traveled. So hopefully this gives you some good information on how to solve word problems using the definite integral. Remember, a definite integral represents the area under the curve if the curve is non-negative. Otherwise, it will represent the net change.